Look at any major global port and you see millions of moving parts. Ships docking, cranes swinging, trucks hauling, a massive, relentless physical network. For years, the tech industry promised to manage this physical complexity through data visualization. We built massive data pipelines to feed centralized, color-coded dashboards so humans could monitor the flow. But the result was dashboard fatigue. Operators today are often paralyzed by a constant barrage of passive alerts and red flashing lights that indicate a problem without offering any means to resolve it. Increasing visibility without providing a mechanism for action fails to create control. It simply buries the human workforce under an unmanageable cognitive load. This disconnect creates a specific operational bottleneck called insight latency. This is the exact time gap between a real-world logistical error happening on the ground and a human finally noticing the alert on their screen. This timeline shows how a single wrong digit on a customs form, like an incorrect HS code, stalls the entire chain. An HS code, or Harmonized System Code, is a standardized numerical method used by customs authorities globally to classify traded products. The error travels through cloud ingestion, sitting frozen on a static dashboard. While the human operator waits to react, the physical window to correct the document expires. The container stays held at the border, incurring thousands in fees. Legacy automation tools like robotic process automation cannot bridge this gap. RPA requires perfectly structured data to function, so it breaks down when faced with messy PDF tariff manuals or thermal images of damaged cargo. Every minute of insight latency directly drains a company's profit margins, converting technical delays into permanent revenue leakage. Solving this requires a shift from passive data visualization to data actuation, building systems that can execute the actions their data suggests. This schematic outlines the replacement for the dashboard, the control tower. Instead of a linear pipeline ending at a screen, it is a circular, autonomous system. The agent's brain runs on a react loop, forcing the AI to observe context and plan before executing. But reasoning alone is insufficient. The agent needs deep operational memory to recall and apply massive volumes of complex logistics rules, supplier constraints, and dense compliance manuals. Replacing a human at the bottleneck requires an AI that cognitively maps out a multi-step resolution plan instead of merely flagging an anomaly. This leads to a practical question. How does a piece of software reasoning in the cloud actually execute a physical logistics decision? This diagram demonstrates the Model Context Protocol, an open standard giving AI models secure plug-and-play connections to remote data sources like ERPs. Through this connection, the agent reaches into inventory systems to autonomously draft freight claims or submit expedited reorders. Standardizing this connection between a reasoning brain and operational software hands is the mechanism that finally closes the insight latency gap. Letting an AI make autonomous decisions triggers immediate executive anxiety. No company wants an AI to hallucinate and accidentally approve a $1 million freight refund. The engineering solution to that risk is building a strict AI posture through deterministic guardrails. These guardrails mathematically validate the AI's proposed actions against hard-coded business rules. If a command violates corporate policy or exceeds a spending limit, the code blocks it before it ever executes. Enterprise trust is achieved when unpredictable AI reasoning is forced to pass through inflexible, deterministic code before impacting the real world. With guardrails in place, the human operator's role evolves. They stop being overwhelmed dashboard monitors and become orchestrators of AI fleets. The AI becomes a digital teammate, a specialized paralegal or procurement agent that handles the cognitive heavy lifting of repetitive workflows. Instead of humans executing dozens of fragmented checks, the AI finds lost stock, cross-references databases, and compiles a complete resolution package awaiting a single human approval. Deploying these agents at scale transforms a reactive supply chain into an active, self-optimizing digital twin. Recovering even a small percentage of traditional freight write-offs translates into pure, immediate profit margin. Data is a physical commodity that must be delivered to the point of action in order to hold its true value. The future of global logistics belongs to those whose data can execute on its own.